So today we're going to be taking a look at how to name these compounds called aromatic compounds. Aromatic compounds are derived from the molecular formula C6H6, also known as the benzene ring. And the benzene ring looks like a cyclohexane. However, there are 3 double bonds around your cyclohexane. So aromatic compounds have a noticeable fragrance to them. They can often be found in paint, paint thinners, detergent, gasoline, and you'll see that in worksheets and in the future, the way that aromatics are drawn can be represented by 3 double bonds, or that is equivalent to a cyclohexane with a circle at the center. And that is because these double bonds are in constant movement. So they're in constant movement within the compound itself, and we call these double bonds to be delocalized. So they're constantly moving from one carbon to the next, and that actually causes great stability of the molecule, which can be an issue because some products that I listed before contain benzenes and are so stable they can be carcinogenic. And again, that is because of how delocalized their bonds are. So here's some common compounds with the benzene ring. You'll notice that when we're naming, if it takes priority and it is the parent, it takes the parent name, we refer to it as benzene. But if it's a side group or a substituent, it is known as a phenol. Okay, here's some other common molecules that contain benzene. One that you'll see quite often is this phenol, and it's pretty much a benzene ring with a hydroxyl group or an alcohol attached to it. So let's do a couple of examples. The first one you can see has a benzene ring as well as a methyl group and a bromo group. So we're going to go back to our normal rules from the last 2 lessons, and since B comes before M in the alphabet, we're going to name our bromo first. So I know that it is 1 bromo, 4 methyl, benzene. Your parent chain is your benzene ring. The other example you can see is a long hydrocarbon chain with a double bond and 2 benzene rings attached to this long hydrocarbon. So because I have a double bond attached on the left side, I am going to count based on the left side. So this is an octane, or an octene because there's a double bond. So I'm going to name accordingly, and I know that my parent chain needs to be an octene. So I have 2 phenyl groups. Remember, when they are side groups or substituents, they are no longer called benzene, but they're called phenyl groups. So this is 4-6 or 4,6 dash diphenyl oct. My double bond is between 2 and 3, so oct-2-ene. So you can see here in this example, my benzene is a phenyl group, whereas in example 1, we treat it as a parent. And when you're doing these practice problems, it's going to be obvious whether it's the parent chain or the side group. So here, example 3, we have a benzene, we have a methyl, this is an ethyl, methyl, iodo, fluoro, and chloro. And just based off going alphabetically in order, chloro will be assigned carbon 1. So we have 1, 2, actually, we're not going to go this way because our F, fluoro, comes before M for methyl. So we're going to go 1, 2, 3, 4, 5, 6. So our name is going to start alphabetically. So 1, chloro, dash 2, fluoro, dash 3, iodo, dash, oh, I just realized that there is an ethyl. So I need this to be before my F. So we have 5, ethyl, 2, fluoro, 3, iodo, 6, 2, 4, 6, because there's 2 methyls, dimethyl, and then we have our benzene. Okay, so I have 1 chloro, 5 ethyl, 2 fluoro, 3 iodo, 4, 6 dimethyl benzene. And my benzene ring is the parent. Sometimes you'll see that the old way of naming is used instead of IUPAC naming with your benzene rings. Okay, so what does that mean? Instead of using prefixes that we're used to in IUPAC nomenclature, we use these words ortho, meta, and para. So when a benzene ring has only 2 branches, we can use these prefixes, which are test-worthy. And these prefixes tell you where the branches are. So one way I like to remember what each one of these prefixes means is the acronym BOMP. So benzene. So all benzene rings, ortho, meta, para, in order. So 1, 2, 1, 3, 1, 4. So what that means is if I have a benzene ring and there's only 2 branches, if there's only 2 branches, I can determine whether it's ortho, meta, and para. So this one methyl is at carbon 1, and this second methyl is at carbon 2. So instead of saying 1, 2 dimethyl benzene, I can just write ortho dimethyl benzene to represent the 1, 2. If I take a look at the second one, my methyl group is at carbon 1 and carbon 3. I can call it 1, 3 dimethyl benzene, or I can denote the 1, 3 as metadimethyl benzene. And then for my para, both of these side groups or branches are at 1 and 4. So instead of calling it 1, 4 dimethyl benzene, we have para-dimethyl benzene. Just again to reiterate, the benzene ring can be treated as a parent or a substituent. In this case, we would refer to it as being a phenyl group. Okay, some more examples. So benzene is the parent name when you are given halogens on the side or alkyl branches or hydrocarbon branches, same thing as alkyl branches. But for example, this first one, because there are only two halogens, so chloro at 1 and 2, our parent chain or our parent is the benzene ring itself. Again, a common compound that you'll see is the benzene ring attached to an OH or a hydroxyl group. And then this last example, when there's a double or a triple bond on a long hydrocarbon, now your benzene ring is no longer the parent, but it becomes the side group.